Hello, we're going to look in this video at solving trig equations involving identities. And again, you should know at least these identities, and certainly the more basic ones like cotangent theta is the same thing as 1 over tangent theta or cosine theta over sine theta. But these you should also commit to memory. So in this example then, we're looking at sine squared theta minus cosine 2 theta equals -1/4. And we're looking for solutions from 0 to 2 pi. All right, now my thought process is I have a second order equation, right, power of 2, and then that's sine, and then I have a different trig function, which is cosine, and it's a double angle. So this is really, really different. So then I think to myself, is there any way I can get everything in one trig function, like the same trig function? Because that would surely be nice. So it looks like cosine 2 theta, so I've got sine squared theta is 1 minus cosine squared theta. That's a possibility, but this is the second power of a single angle, and this is a double angle. So I wouldn't be able to factor and say they're the same thing. However, cosine 2 theta has this form, 1 minus 2 sine squared theta, and that's kind of nice because now you're talking about a second power and of a single angle. So that will be the same as this. So I like that. I prefer that. So I'm going to try that first. So I'd say, okay, sine squared theta minus, now instead of writing cosine 2 theta, I'm going to write 1 minus 2 sine squared. And now I'm going to put parentheses. The reason being, if you forget to put parentheses, you'll forget to distribute this negative sign to this negative sign. So just be careful about that. Okay. And now we continue solving. So here we get sine squared theta minus 1 plus 2 sine squared theta equals -1/4. Right? And now I have 2 sine squared thetas and another sine squared theta for a total of 3 sine squared thetas. Right? And then we have this -1. I'm going to move over to the other side. So I'm going to add 1 over here. So now I have 3 sine squared theta equals to 3/4, right? Now, at this point I probably want to go ahead and solve for just the sine squared, so I'm going to go ahead and multiply by 1/3 or divide by 1/3, however you want to look at it. So sine squared theta is equal to 1/4. Now I've isolated the trig function, right? Because sine squared theta is really the same thing as sine of theta squared equals 1/4, right? I'm solving, whether I write it this way or write it this way, it's the same thing. So essentially I'm trying to isolate theta eventually, but I have a square that I have to undo, so what I'm going to do is take the square root of both sides. So when I take the square root of sine squared theta, square root of 1/4, now the square root of something squared is the absolute value of that thing. So here we go, absolute value of sine theta. And technically this is the square root of 1 over the square root of 4, right? So that's really going to be 1/2. So the absolute value of sine theta is equal to 1/2. But now when I remove the absolute value, I'll have sine theta equals plus or minus 1/2. Right? So now I've got to solve two separate things. I've got to solve sine theta equal to -1/2 and sine theta equal to +1/2. Right, so on the next page we'll carry that over. I'm going to make that a tad bit cleaner. So if I look at sine theta equal to -1/2 versus sine theta equal to +1/2, all right. Now, technically, theta equals the inverse sine of -1/2, and you could put that in your calculator, but honestly that should be something that's pretty easy to tell from your knowledge of the unit circle, right? So here I'm asking for what angle, somewhere between, well, technically -pi/2 and pi/2, is the y-coordinate, because it's a sine function, a length of -1/2, right? So, get a different color here. And that would be somewhere here, right? Here and here. So I'm looking for that angle and that angle. So I can say here, technically your calculator would give you negative pi over 6. However, we were asked to solve this between 0 and 2 pi. So I would also call that 11 pi over 6. And this would be 7 pi over 6. Now here I'm capturing solutions that the calculator would not give you, right? So that's where your knowledge of the unit circle comes in. And then here I'm looking for what angle is the y-coordinate a positive a half. So that would be like here and here. So we're looking for those angles. Pi over 6 and 5 pi over 6. Okay? So those are, so from 0 to 2 pi, right, your solutions are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right. Thanks so much for listening.